Welcome to my talk, which I have named Competencies for a Modern Workforce in Mechanical and Aerospace Engineering Paradigm. My name is Dr. Felix Ewere, and I am currently a professor of the Department of Mechanical and Aerospace Engineering at North Carolina State University, Raleigh, United States. A little bit about me. I was born in Nigeria, like most of you. I went to high school in Lagos, and the University of Lagos is where I got my bachelor's degree from. I got a bachelor's degree in mechanical engineering, and later got a job with the Nigerian Space Agency called NASA. I worked there for a little while and decided to go pursue a master's degree in aerospace. I got a master's degree in aerospace engineering and a PhD in mechanical engineering. And that's why I have been a little vast doing mechanical and aerospace engineering things. You might ask, why did I choose mechanical and aerospace engineering? Well, that is because of a few things. One, I love math. I was good at it, and I just couldn't stop doing it. I love science, I was inquisitive, and I just like to explain how things work generally in life. Mechanical and aerospace engineering requires you to have a creative mind, to be able to think holistically, and most of all, to try to solve problems that you find around you. The talk today will be about those skills and abilities that we should have if we want to be part of a modern workforce. I will start by looking at engineering, mechanical, and aerospace engineering as a whole, and then look at the possible path, the career that a mechanical and aerospace engineer can take. And then I will also look at aerospace engineering. Nigeria is not really big in aerospace, so I will talk more about aviation, that is civil aviation, which is what we have in Nigeria. And I'll also describe the competencies that you need, but generally for a workforce, and how this can help us. Basically, I'm just trying to help us begin to think about those qualities we may have to be able to perform in Nigeria, internationally, or wherever we find ourselves. I have gotten to this point in life by just doing whatever I do well. And if you have that policy, I think you will go far in whatever you do. So, I'll see you in the next video where I begin to talk about mechanical and aerospace engineering. Okay, welcome back. Let's talk a little bit about mechanical and aerospace engineering. Mechanical or engineering can be seen is regarded as a STEM discipline, which is science, technology, engineering, and math. Science basically is a systematic study of the physical and natural surroundings, and technology is a product of engineering. So engineering is the application of the study or application of science, while technology is products we get from science. your cell phones, the car you drive, or technologies, whereas engineering is the art of making all of those things. But then to do them, you need to study and understand them, and that's where science comes in. And of course, math is the language we speak in engineering and science. It brings in logic, it helps to understand or explain those things so that we can relate those abstract content to physical, give physical meaning to those abstract content. And generally in STEM disciplines, we would have to have these main skills. One of them is an aptitude for math, which is you really need to be able to speak that language so that the logic of how these things work will be clear to you. The next thing is an ability to think logically. A lot of this is commonsensical, but you would have to be able to think about it. Creative thinking is also needed because most engineers are problem solvers, so we also have to be solving problems. And of course, the drive and determination to do the work that's required. This is very important because sometimes the problems engineers are about to solve might seem insurmountable, but if you have the drive and determination, you'll be able to do well. So, let me make a distinction here. Mechanical comes from the word mechanics, which is the study of motion and the forces causing that motion. One could say this is another word to explain Newton's second law, whereas aerospace is the study, as it says, aero, which means air, and space, which means sensible, things outside the sensible atmosphere. Therefore, in mechanical, anything that moves can be studied, and that's why mechanical engineering is seen as the most general form of engineering. Aerospace and mechanical are very, very related, and that's because the fundamental contents are the same. They only separate because aerospace mainly deals with things that fly, like your airplanes and rockets and helicopters and things like that, whereas mechanical deals with a lot of things that you see around you, automotive, biomedical, things like that. Okay, welcome back. Let me give a little more distinction between mechanical and aerospace engineering. As I mentioned earlier, mechanical deals with motion and the forces causing this motion. So mechanical engineer, for example, look at how fluids move. This we'll call fluid mechanics. Whereas an aerospace engineer, which is just dealing with air, will look at how air moves, which we'll call aerodynamics. They will both study structural mechanics, but the aerospace engineer will be looking at materials that are light enough and strong enough so that you can fly better. They will look at things like heat. So for mechanical engineer, you will have heat and mass transfer and thermodynamics, which is how heat moves. Whereas an aerospace engineer will be more concerned with propulsion, which is how you can use all of these materials to produce forces that can push your airplane or your rocket. So mechanical will deal with more general things, whereas aerospace will be concerned with specific things concerning flying on Earth and going to space. So aerospace engineering will be generally divided into two main categories. So engineering has to do with the design and development of spacecraft, that is things that will go to space, and other uses, things in space, like satellites and rockets and space shuttle and things like that. Whereas the other, which is aeronautical engineering, will deal with planes and rotorcraft like helicopters and drones and general things that we use atmospheric air to fly. Initially, aerospace engineering was actually only known as aeronautical engineering, and that was because it took some time before we could actually start going into space. Now, aeronautical engineering has to do with a lot of development, which is building planes and helicopters. So in Nigeria, for example, we don't build our own planes or build, things that have to do with flying in sensible Earth. So what we do mostly in Nigeria has to do with operation. We operate all of these vehicles that are being built because they are actually very difficult to build. So in Nigeria, we deal mostly with aviation. And aviation is what we call air transport, which is the operational part of aeronautical engineering, if we would say. So aviation has to do with things that surround flying. Basically, civil aviation has to do with mechanical flight and the aircraft industry. So that in aviation, some of the jobs we'll be looking at or we can have will be things like a cabin crew, which is the host and the hostesses we see on there, the administrative support, operations agents, people who book your flight, avionics technicians, flight dispatchers, the meteorologists because the weather is very important, planners, and space representatives. One of the things we can actually separate from this is avionics. Avionics is the electronics of flying. Well, that will be a lot more concerned with instrumentation and electrical engineering, and that's a discussion for another day. So in terms of aviation in Nigeria, a couple of players are very important for us to know. One of them is the Ministry of Aviation, which sort of controls air transport generally in Nigeria. And then there's the NCAA, National Civil Aviation Authority. They sort of maintain all of the, flying of civil aviation, which is all of the airlines we have that we see, like Aerospace, Air Peace, and all of those airlines which we take everyday flying in different cities. There are also companies that there are also places you can go and get well educated if you want to learn and know more about avionics and aviation. Nigeria also has the Nigerian College of Aviation Technology, which is a high institution based in Zaria, where we can learn and take a lot of courses to be part of the aviation industry, if you wanted to. One of the fundamental things is being a pilot, so that in aviation, when you know how to fly a plane and you can go to school to become a pilot, you will be able to fly planes very well. I cannot mention how lucrative this discipline can be. There is a lot of money involved here if this is the field you intend to go in. A pilot will know how to fly a plane, but will not know how to build one, whereas an aerospace engineer will know how to build a plane, but not necessarily how to fly one. So, let's look at career paths in mechanical engineering. So as a mechanical engineer, and this actually applies to most forms of engineering, since mechanical is the most general form, we're looking at mechanical engineering. So industry, what that means is you can work, in operations. You can go and work for companies like Coca-Cola or Procter & Gamble, or just, companies that manufacture stuff and do a lot of different kinds of things. So you can go and be in the operational part of engineering, where you do jobs, that help in production, manufacturing, and things like that. And then there's technical sales and marketing. You can be part of marketing for some companies where you know enough about their products and you go and you help to sell and market their company. We have engineering social services, where you are in the public domain and help with public services, social services. Social services are in the public domain, and you help with things like building bridges for the government, or generally maintenance of roads and things like that the government do. So that definitely means you can work for a federal, state, and local government, whereas an engineer for the government, you can help supervise several of the projects that are being done every day. Another aspect is education. You can go into education, which is you can decide to teach probably at the tertiary level, or you could do this in the high school level. In the military, for example, the Air Force and even the Army, the Navy, a lot of engineers that work for them, they are very required because, example, in aerospace, a lot of what is done is also very important for defense, because these days, to fight the modern warfare, you would need a lot of engineering capabilities and technologies, which military would need engineers for. Research and development, that is one that I do, where you figure out things, you try to find out how things work, and know how you can use them to develop new technologies and new ideas. Technical consulting, that has to do with you being part of a company that specializes in something, and you can also consult. What that means is other companies can reach out to you for that particular skill or technology that you have, and you can work for them. You can also be an independent entrepreneur. What that means is you can also start your own business, which is one thing that I encourage all of us to do. Finally, graduate school, which is something that I did, which is you go, you know more, and eventually do research and development, or you can still, become or go into education after that and be part of the tertiary institutions, or you work in an industry. So, generally, mechanical engineers can do any of these jobs because of how much they would know and general things they can do. There is petroleum engineers, automotive engineer, materials design, just all of this that you see here. One thing I'll give as an advice here is, whatever field you intend to enter, you have to do your research. For example, automotive engineering is changing. The days of the internal combustion engine and using fuel or gas to power your engine is changing. Things are moving on to driverless cars and electric vehicles. That is what we're going to be the future of automotive engineering. So you might want to consider going into a field where you're looking at electric cars and driverless cars, instead of going back to where we're using gas. And I also must let you know that there is a lot of money in this field too, but what I advise is, do not chase money, chase a career, the money will come. And let's talk about competencies now. Just the main thing we want to talk about today. So there's several definitions, but I like this definition for what a competency is. And that is that it is a cluster of related knowledge, skills, and abilities that affects a major part of one's job. So what are those skills, what are the knowledge, the things that you have to know to be able to do well? And that's a competency. Alright? So, a little bit about self-discovery here. Now, what I'm trying to point out here is that everybody is good at something, but you need to figure out what it is that you're good at. Some of us can run faster, some of us can think faster, some of us are good at math, some of us are good at, drawing and things like that. You need to figure out what you are good at. Now, if whatever you do is easy for you to do that, that's probably one of the signs to show that you are good at it. Because to be successful, two things are very important. First is the talent, those things that you have that are natural, innate, that come with you. And then working smart or working hard, which is perspiration. So it's a good combination of both that will make you actually do well. But if you don't know what your talent is and you're working so hard in that section or discipline, it might be difficult. But sometimes you still see people who do very well. So, be good at something, but then you have to try to know things and work hard at it, which is where you have to learn things. Now, there are several levels of learning, and I just wanted to point this out because it is good for us to understand how the process works. And I'll give this example using a skill or competency like driving. First level is what we call the unconscious incompetence, which is when you don't know that you don't know. So for example, when you were young, when you were 4, 5, 10, and you couldn't drive, and all you did was sit behind your parents' vehicle and they drove you everywhere. You probably didn't think about driving or whether it's difficult or not. After that, let's say you're grown and you're a 20-year-old, for example, and now you need to drive. When you get into the car the first time, you will figure out that there are things that you don't know. And that's what we call the conscious incompetence state. You're still incompetent, you don't know how to drive, but now you want to learn. And this is the point where you start asking questions. Now, asking questions is very important. And after asking those questions, if you're getting those answers, for example, in driving, you get into the third stage, which is the conscious competence state, which is now that you know enough and you can drive, for example, but you're still thinking about it. So, to drive, your legs and your hands need to do something. At this point, it's not second nature yet. So your brain is knowing that your legs are pressing the gas or the brakes and things like that, and how your hands are moving, changing, the different things you need to drive. Now that is a conscious competence state, because you're still thinking about it, but at least you know enough to do it. The fourth stage is now the unconscious competence state, which is where you are not thinking about it anymore, and you can just enter your car and drive without wondering about it and things like that. This is when you know how to do something through an unconscious habit, and at this point you must have done a lot of repetition. There is a fifth stage called conscious unconscious competence, which is that you might know something enough to do it unconsciously, but to be able to teach it, you have to be conscious to be able to teach it. So, for example, the guy teaching how to drive or your professor at college are at that conscious unconscious competence state. So these are the levels of learning, and I advise that you try to be at the unconscious competence level at least. Now, this is one of the problems we see with social media, because there are people who are at the unconscious incompetence level, but they have something to say about everything. So don't waste your time on social media. Focus on things that will benefit you. Now, for an engineer, these are some of the qualities that are very important. We've talked about STEM skills, but there are soft skills. Things like how to communicate. That's very, very important. How to be a team player. Actually, when you go in an industry, most of the things you do, you have to work with people, so you have to be a good team player. And it might sound abstract, but you have to learn how to be a team player. You have to be curious. We talked about this earlier. Practical and resourceful, because there will always be problems that are in front of you and you have to solve them. Another very important thing is ethics. Engineers build things, we do things every day. You have to be ethical about it, which means if you're building a bridge, for example, you have to make sure that you use the right equipment, the right materials. You have to make it strong and things like that, because if an engineering fixture, say a bridge or a car fails, people might die. So we have to be ethical about it, and it's actually a very big deal in engineering. In operations, for example, these are some of the skills that are important. If you go into design, for example, you would need skills like computer-aided design, what that means you have to be able to use software like SolidWorks or AutoCAD or ProRe to be able to draw things and even do some kind of simulations. Production, you have some operations management and instrumentation, fabrication skills. Sales, you have to be able to do calculations using a spreadsheet, modeling and simulation. Planning, project management, systems engineering, all of that comes in. And of course, maintenance. A lot of the routine work mechanical engineers do is maintenance, which is where you are part of, say, a production company, and you are there with the everyday daily routine of that company. Okay? So let's now look at the competencies. Hi, I would like to use the competency model clearinghouse run by the U.S. Department of Labor to explain a little bit about general competencies that engineers need. And specifically, we'll be looking at the aerospace industry in this case. Now, these are skills that we need, personally, academically, in the workplace, and even when we get to the top echelon of our discipline, like we'll have become head of a company, and things like that. The U.S. Department of Labor uses this model, and for several disciplines, if you go to competencymodelclearinghouse.com, you would find all of this. If you Google careeronestop.org, you would see all of this. And even if you're not an engineer, there are models for several disciplines that can be used. So, let's look at Tier 1 to 3. This is personal effectiveness. Now, these are things that we have to have just as individuals to be able to do things well, to have that drive, to have that determination and professionalism to do things very well. So some of the things or these competencies you should have are things like integrity. You have to have integrity. It's very, very important. A lot of the time, people will only deal with you when you have integrity. A lot of us have different definitions for that, but fundamentally, you have to do anything you're doing very well. Professionalism is one of them. You have to separate business from personal. You have to have that initiative, lifelong learning, and interpersonal skills. You have to be able to relate to people. Academic competencies, these are things that we can learn in school. Personal effective competencies, you probably will not be taught that in the academic environment. These are things we learn because a lot of it are soft skills. Academic competencies are things that we can learn in school. Reading, writing, math, science, all the computer skills we would need, and things like that. Third is workplace competencies. After you've learned all of this, what are those skills you need for work? For example, there is no employer that will ask you to do the YDS or solve some calculus or engineering equation at work. You are going to just use what you have learned in school at work. So, planning and organizing is a big one. You have to be able to comport yourself, time management, and things like that. And problem solving and decision making. Very important too. You're going to be given problems and you have to be able to think and solve them. Teamwork, like I mentioned earlier, is also important. Business fundamentals. The modern workforce these days requires everybody to think like a businessman. And eventually, actually, start your own business. That's a very good, way to do things now. Tier 4, Tier 5 are just higher level competencies that we would need depending on the industry that we are. So Tier 4, for example, is where ethics come in. Like I said, it's very important to be ethical in engineering. Design and engineering economics all come in, and of course business, legal, and public policy part of it. And it's, you're lucky you work hard and get to the management level of your desired discipline. These are some of the competencies you would need to have as a manager of a company. You have to be able to, delegate duties, develop and mentor people, be strategic with planning, manage conflict and team building, develop an organizational vision, networking, staffing, several things like that you would need. So I would look at some really now brand new modern competencies that we need to have in the next video. Look at a few things before we conclude. Here's my advice: join a professional organization. Be a student member. There's so many benefits to be a member of a professional organization. One of them is you get, student rates, for conferences and things like that. Even if you're not able to go to those conferences, just knowing about, the latest things about any discipline that you're in is a very good thing to know. And being a member, so, very important. Now the Association of American Society of Mechanical Engineers is a good one for mechanical engineers. American Institute of Aeronautics and Astronautics is the leading society, for aerospace engineers. And there's also the AIAA, Institution of Mechanical Engineers and Mechanical Engineering. All of these bodies have student organizations in Nigeria, and you can be part of them even, while you are not working yet. And we also have the Nigerian Society of Engineers and the Nigerian Institute of Mechanical Engineers. Okay, be part of these bodies to help. Now, the world has gone digital, so everything that we do now is, online, virtual, and things like that. So let's look at a few things, for the future of most of the engineering field and things, that we would use later in life. And if we were, to go into any of, the disciplines or have these competencies, that would be a good thing, in the modern force for the future. These are, a few of them are this: artificial intelligence. Okay, this will help with robotics and things like that. Basically, trying to mimic reality. That's a big one. Virtual reality. For some of us who play video games and the rest, we already see this. So being at the back end, being able to help with, making all of this is also some skill that we might want to incorporate. Machine learning, neural networks. That's also a big deal where we try to use probability to learn, or train a software, and it can actually just do things. There are also software development. These days the need for software to make several technologies cannot be overstated. Then there's cybersecurity. That's a big deal too. You might want to, use that. All of those skills, okay, are things that can be used in aerospace engineering, mechanical engineering. They're all very important engineering. And finally, it's battery technology. And that's a big deal because it's actually gradually revolutionizing the entire world. Sometime in the future, we're going to have planes that will fly, first of all, in a hybrid mode where they have fuels and electric power, but eventually cars, planes, and everything that moves will move on to electric or battery technology, and that's because the advantages is so much. It's clean, there's no noise, and things like that. So the world is digital. Whatever form of engineering you're doing, if you think about it, to be part of the modern workforce, you have to also go digital. Finally, we'll have to think beyond the job. Okay, so what are those things that I can do beyond just a job? So a few things you want to do is, first of all, see yourself as an asset. You are an asset, okay? And whatever job you're applying for, whatever you do, just see yourself that you are an asset that needs to be managed, and try to manage yourself well. Okay? Time is all the currency you have. So what you do with your time is extremely important. You want to make sure you manage your time and you do well. Because there's so many distractions these days, so good time management is very important. Okay? Another thing is find the need to fulfill. You look around you, there's always something that needs to be fulfilled. There's always one problem around you that you can solve. A lot of the time, most of the great men, most of the great businesses have always come from fulfilling a need. And if you look around us here in Nigeria, there's so many things that can be done. So find a need to fulfill, and also try to help your community. In your own way, own little way, try to help a community. Okay? So if you do all of that, business can come from it. Alright? So that one day you will also be an employer. So think about it, try to be an employer yourself. Alright? And eventually, I think you should do most of the things we've talked about today. With all the competencies, with all the drive, the determination, perseveration, self-discovery, I think it will go on. Thank you for listening, and let me know if you have questions.